Welcome guys to my channel. This is Chemistry with Min. Today,
Alright guys, we'll be starting how to get the molar mass of an object. Okay, so let's pretend we have water. Let's see here, water, H2O. So how we will find the molar mass? So, ilan ang ano natin? Sorry. So ilan ang hydrogen natin? Di ba dalawa? So, 2. Dalawa ang hydrogen. Ita-times natin siya sa mol. Saan natin siya ita-times? Sa atomic mass. So, ang atomic mass ng hydrogen is 1. Now, ilan ang oxygen natin? Yan. So, we only have 1 oxygen, so 1. But what is the atomic mass of oxygen? Which is 16. Now let's multiply it. So hydrogen is 2 and oxygen is 16. So if you add them together, that's 18. So 18, so 18, and our unit is grams over mole. Okay, very good. Okay, let's try another example. Let's have glucose, C6H12. So how many carbon that we have? Do we have right now? So we have 6 carbon. The atomic mass of carbon is 12. There. Hydrogen, we have 12 hydrogen times, how many hydrogen? 12. And then what's the atomic mass? 1. And oxygen, we have 6 oxygen. So what's the atomic mass of oxygen? Which is, oxygen is 8. No, it's 6, sorry. 6 oxygen times 16. 16 is the atomic mass. All right. Now let's multiply it. So 6 times 12, 72. So 12. And then 6 times 16, it's 96. Now if you add them together, so 72 plus 12 plus 96 equals 180 grams per mole. That would be our final answer. There we go. Okay, let's try another one. Let's try something that we can applicate. How about sodium? Sodium, sodium carbonate. Okay. So sodium is Na, and the carbonate is Na2CO3. Okay. How many sodium that we have in order to get the molar mass? All right. I'll just label this. Okay. Molar mass. This is the molar mass lecture. Okay. All right. Here we go. So N is equals to 2 times, what is the molar mass of sodium? If you can still remember, guys. All right. The atomic mass of sodium is 22. And then we have one carbon, which is 12. And then we have 3 oxygen, which is 3 times 16. Now, let's multiply all of them. So, 2 times 22 is 44. 12. So, 16 times 3 equals 48. So, let's add them all together. 44 plus 12 plus 48 equals 104 grams per mole. There you go. You have that. All right. Let's try another one. Let's have paracetamol. So let's see what's the compound name of paracetamol. Okay. Paracetamol is C8H9NO2. This is paracetamol. So, how many carbons that we have in paracetamol? We have 8. 8 times 12. That's the atomic mass. Next, hydrogen is 9 and the atomic mass of hydrogen is 1. Very good. And then nitrogen, how many nitrogens that we have? We only have 1. So times 14, which is the atomic mass of nitrogen, and then we have 2 oxygen, which is 2 times 16. So let's multiply all of them. So 8 times 12, that's 96. 9, 14, 36. No, sorry, 32. Okay, 32. So let's add them together. 96 plus 9 plus 14 plus 32 will give you a grand total of 151 grams per mole. Okay, that would be our final answer. So, let's move on to the next topic. Okay, now we're going to learn how to convert grams to mole. So, how to do that? So, let's pretend that we have 9 grams of H2O. Let's pretend. We want to convert it into mole. So we have 9 grams of H2O multiplied by 1 mole over what's the, okay, if you can still remember, what is the molar mass of water? So the molar mass of water is 18. So we have to divide it. So 9 divided by 18, that's 0.5. 0.5 mole. And that would be our final answer. So let's try another one. Let's pretend that we have glucose. There you go. That's glucose. Let's pretend that we have 10 grams of glucose. convert it into mole. So, 10 grams of glucose, okay, multiply 1 mole over 180 grams. So where did we get 180? It's the molar mass of glucose. So 10 grams divided by 180. So 10 divided by 180, and that's the answer is 0.05 moles. All right, now that we got it, let's try another one. Let's pretend that we have 35 grams of sodium chloride. All right, sodium chloride. Let's have sodium chloride. So we don't know yet what's the molar mass of sodium chloride or salt. So how many sodium that we have? Okay, it's molar mass. Okay, we only have one sodium. So what's the atomic number of sodium? If you can still remember, it's 22. There we go. And then, what is the atomic mass of chlorine? So, chlorine atomic mass is 35. All right, let's put that here. 1 times 35. There we go. So now the next step is to add them. So 22 plus 35, that's 57 grams per mole. Right. So now that we have this, so 35 grams of sodium chloride times 1 mole over 57 grams. So now let's divide it. 35, all right, 35 divided by 57, and that would give you 0.6 moles. This is how you convert grams to moles. Okay, let's have another example. Let's have another example. There you go. All right. Okay. Let's have something a little more complicated. All right. Let's have risperidone. So, risperidone is the antipsychotic drug used to treat schizophrenia and other diseases. So, the chemical formula for that is carbon is 23, H is 27, hydrogen is 27, 1 chloride, chlorine, and nitrogen, and oxygen. So, first step 1, get molar mass. So, we have 23 carbon, and the atomic mass of carbon is 12. Hydrogen, we have 27 hydrogen, and the atomic mass of hydrogen is 1. We have fluoride, so we only have 1 fluoride, and the atomic mass of fluoride is 18. And, and for nitrogen, we have 4 nitrogen in the equation. So 4 times 14. And then we have oxygen. We have 2 oxygen. And the molar mass, the atomic mass of oxygen is 16. So now we have that. Let's multiply everything. So 23 times 12, you have 76. 276. And then we have 27. We have 18. So 4 times 14, that's 56. And then 2 times 16, that's 32. Now that we have that, let's add everything together. 276 plus 27 plus 18 plus 56 plus 32 and have 409 grams per mole. Now, let's say that we have 705 grams of risperidone. So now that we have this, we can convert this now to mole. Alright. So 409 grams. We have 409 grams, right? That's our molar mass. So we want to find the mole of this equation. Okay. So 705 grams times 1 mole divided by 409 grams is equal to 705 divided by 409. So we have 1.7 mole. That would be our final answer. So let's move on to the next topic. All right. Let's move on to our next topic, how to convert mole to gram. All right. Let's have 5 moles of H2O. All right. So we wanted to convert into grams. So first step, we have 5 moles times 1 over mole. And in the top part, we'll multiply it with the molar mass. What's the molar mass of water? It's 18 grams. So let's multiply it. So 5 times 18, that would give us around 5 times 18. That's 90 grams. All right. Okay. Let's try another one. 10 moles of glucose. There you go. All right. 10 moles of glucose. So we want to convert it into grams. So 10 mole times, what's the molar mass of glucose? It's 180 grams divided by 1 mole. So it would give us 1,800 grams. That's how you get it. Okay, let's try another one. Let's have something a little more complicated. I was thinking of what? Okay. Let's have chlorophyll. chlorophyll is C55, 55 carbon, H is 72, magnesium, nitrogen, and oxygen. There. This is chlorophyll. Just fun fact, chlorophyll is usually found in plants, coloring, which is a coloring of the plants. Okay, we have C. Okay, first step, get the molar mass. So we have 55, 55 carbon, and the atomic mass of carbon is 12. Then we have H, or hydrogen. We have 72 hydrogen, and the atomic mass of hydrogen is 1. Mass, magnesium. We have one magnesium, and then the atomic mass of magnesium is, let's see, 24. There you go, 24. Nitrogen, we have 4 nitrogen, and then 14. 14 is the atomic mass of nitrogen, and oxygen, we have 5 oxygen times 16. There you go. Now, let's multiply it. 55 times 12. We got 600. 72, 24, 14 times 4, that's 56, and 16 times 5, 80. Now you got it. So, okay, 660 plus 72 plus 24 plus 56 plus 80 is equal to 892 grams per mole. Now, let's pretend that we have 3 moles of chlorophyll and we want to convert it into grams. So, 892 grams, we have 892 grams, so 3 mole times 892 grams divided by mole is equal to, so 300 times 892, that's 2,676 grams. And that would be our final answer. All right, let's try another one. So let's have something. Let's have well, let's see. Carbon dioxide, 5 moles of carbon dioxide. So we want to convert it into grams, right? So how do we do this? 5 mole times, what's the molar mass of carbon dioxide? So let's get it. 12 times 1. 12 is the atomic mass times 1 carbon. Then 16 is the atomic mass of oxygen times 2 because we have 2 oxygen. So our total answer would be 12 times 32. That's divided by mole is equal to 5 times 4 to 4 is equal to 200 grams. 220 grams. All right. Let's have another one. So let's have this formula. We have 3 moles of meta or LSD, methamphetamine, meta, methamphetamine. So 6, 10 each, 1, 5. All right. All right. So let's get the molar mass of this equation here. So the molar mass, so we have 10 times 12. 12 is the atomic mass, all right? And 10, we have 10 in carbon here. Next, H, or hydrogen. We have 15 hydrogen. And then the atomic mass is 1. And then nitrogen, we have nitrogen. We only have 1 nitrogen, so 14. So let's multiply all of them. So we got 12, 120 plus 15 plus 14. So 9, 4, 1. 149 grams per mole. Now, we have 3 moles of this formula. So 3 moles times 149 grams over mole. And that would give us 149 times 3. That's 447 grams. That's our final answer. Okay, let's move on to the next topic. Okay, let's move on to another topic. Moles, moles to Avogadro's number or atoms. Okay, let's discuss something about it. 1 mole is equal to the Avogadro's number, which is 6.02 times 2 23. It's a large number, isn't it? The atom here. So 1 mole of substance is equal to 6.02 raised to the 23rd atom. See how large is it? All right. Let's try to convert something. So if we have 5 moles of if we have 5 mole here, 5 mole of copper. So what is the Avogadro's number? What is the equivalent at number of particles? All right. So for every 1 mole of copper, there is 6.02 to the 23rd atom. So since we have 5 mole, so we have to multiply it by 5. So so 5 times Avogadro's number is equal to 3.1 times 3.1, oh sorry, 3 to the 10th here. Here's the final answer. Just get a calculator and multiply 5 mole to 6.2, or the Avogadro's number. Remember, this is the Avogadro's number. Avogadro's number. Here you go. All right. Let's try another one. So we have 10 moles of glucose here. So how we will solve that? So how we will solve that? So 10 moles times Avogadro's number divided by 1 mole. Okay, don't forget to put molecules. All right, now let's multiply it. 10 times the Avogadro's number So we will have 6 raised to 24 molecules. Molecules. All right. All right. Let me fix this. Sorry. All right. Let's try another one. Let's try another one. Let's get silver. How do we get silver? What's the number of particles in silver? So if we have three moles of silver, we want to know the particles, number of particles. So how we will do that? So 3 moles times 6.02 6.2 raised to the 10th 1 mole atom here, there. Then let's multiply 3 times the Avogadro's number. That would be 18, 1.8 raised to the 24. There you go. There you have it. All right. All right, let's convert. In this topic, let's convert. Here we go. Convert atoms slash molecules to mole. There you go. Okay, let's have an example. We have 3 to the 24th, atoms of helium. So we want to convert it into mole, right? So in order to do that, we have to divide it with the Avogadro's number. So 1 mole of helium divided by the Avogadro's number. Here's the value. Sorry, I forgot. Here you go. Here's the value of the Avogadro's number. Here you go. Now, let's divide this and this, and we'll get 5 moles of helium. There you go. That's the final answer. Okay, let's try another one. Okay, we have 9.23 molecules of H2O. Now, in order to convert this to mole, we need to divide it with Avogadro's number. So 6.0223 molecules of water, 1 mole of H2O, and if we divide this, if we divide this and this, we'll get 0.15 mole of H2O. Okay, let's try another one. Okay, let's have 6 to the 24 atoms of calcium. So in order to convert this to mole, we need to divide this by Avogadro's number. So let's set up the equation. Okay, so we will get 10 moles of calcium, and that would be our final answer. Percentage composition is the amount of each element in compound, can also be expressed in terms of percentage, the ratio of the total mass of each element to the total mass of 1 mole of the compound multiplied by 100. So let's have a problem solving. Okay, let's find the percentage composition of the following compound. All right, let's start with water. All right, water. Okay, what is the molar mass of water? So, to get the molar mass of water, H2O, how many hydrogens? There are 2 hydrogens. So, what's the atomic mass? 1. And oxygen, how many oxygen would we have in water? We only have 1. And then the atomic mass, 16. So 2 times 2 plus 16 equals 18. Now, to get the percentage composition, we need to divide this by the total molar mass. All right. 2 divided by 18, 16 divided by 18, and we will get, okay, 2, 2 divided by 18 is, let's solve this. So 0.11. Now, we have to multiply this to 100. And we'll have 11%. And then 16 divided by 18, that's 0.11. 0.88 times 100, therefore 88%. And that's the composition of water. So 11% is from hydrogen and 88% from oxygen. Okay, let's try another one. Composition of calcium hydroxide. So we have this. Calcium dioxide. So we only have one calcium. And the atomic mass of calcium is 40. And then oxygen, we have 2 oxygen. So 2 times 16. And then 2 hydrogen. There you go. So 40, 32, and 2. So 474 grams per mole. Now, let's find the percentage. So let's divide this 3, by 74. There you go. 74, 74, 74. Okay, let's see what we'll get. So 40 divided by 74 is equal to 0.54. 32 divided by 74 we have 0.43, and then finally 2 divided by 74 we have 0.02. So the composition of calcium in this equation is 54%, oxygen is 43%, and water is just 2%. All right. Let's try the last one. Copper sulfide. All right. So copper sulfide. There you go. So what's the atomic mass of copper? The atomic mass of copper is 63. The atomic mass of sulfur 32, and oxygen is around 64. There you go, 64, 32, 63. Now let's add them all. So 63 plus 32 plus 64, that's 159 grams per mole. And then we want to find the percentage of each of the following. So let's divide this by 159. Okay, 63 divided by 159, 0.39. 32 divided by 159, 0.3. Okay, 64 divided by 159 was 0.40. So we have to multiply this by 100. There you go. So this is 39%, 20%, and 40%. Okay, let's try some problem. Okay, what is the empirical formula of a compound containing 52.94% of aluminum and 47.6% of oxygen? So our basis will be 100 grams of compound. So let's get first, you have to get the molar mass. So to get the molar mass of each element, so you have 52.94 grams, 52.94 grams of aluminum times 1 mole over what's the atomic mass of aluminum, which is 27 grams. That's the atomic mass of aluminum. Okay. Then we will get 1.96 mole. Then we have the oxygen. Oxygen is 47.06 grams times 1 mole divided by what's the atomic mass of oxygen? 16 grams. So if we divide that, that's 2.94 mole. Now that we have this, which of the following is smaller? Aluminum or oxygen? So if you answer aluminum, you're correct. So let's divide this by the molar mass of the smallest element. So the smallest element is aluminum, so 1.6 mole divided by 1.6 mole. So we will get 1 mole of aluminum and 1.5 mole of oxygen. Now, to get the empirical formula, since we have 1 aluminum, here you go, 1 aluminum and oxygen, and 1.5 oxygen. Can this happen? Of course not. It should be a whole number. So what do we need to make this a whole number? All right. We have to multiply this by 2. So this will become 2 aluminum and 3 oxygen. And that is our empirical formula. So let's try another one. Okay, what is the empirical formula of a compound containing 5% hydrogen, 50% carbon, and 45% oxygen? So our basis would be 100% again. So let's try this. So we have 5%, 5 grams of hydrogen. So we need to divide this with its, where do we need to divide this? To its atomic mass. Very good. All right. So what's the atomic mass of hydrogen? Equal. So it's 1. So 1 gram. 5 moles of hydrogen. All right. And then we have 50 grams of carbon. So 1 mole is divided by how many carbon do we have? What's the atomic mass of carbon? 12. So let, let's divide 50 and 12. 50, okay, 50 divided by 12, 12 divided by 50 equals, um, 50 divided by 12, that's 4 moles, 4.6 moles. Then finally, we have the oxygen, which is 45 grams. Oxygen. So 1 mole is equivalent to 16 grams. So this is the atomic mass of oxygen. All right. So 45 divided by 16, that's 3.75. Now that we have this, which of the following has the smallest mole? So if you pick oxygen, you're correct. So let's divide this by 3.75. All right, 3.75, 3.75. Here we go. So 5 divided by 3.75, that's 1.3 mole. All right. Then 4.16 divided by 3.75, that's 1.09. And then lastly, 1 mole. There we go. So let's round up everything. Okay. So basically, the formula is this. That's the empirical formula. So we have 1 mole of hydrogen, 1 mole of carbon, and 1 mole of oxygen. And that's the empirical formula.